There's like a lot of noise on my outside, so I don't know if yeah, yeah, the video is gonna be okay. So for the second one, the problem goes like this. The library building is about a library building or like a um, volume problem. So the library roof is formed by the intersection of two curves. Modified parabola described by y equals x to the 2, and a cosine wave given by y equals 2 cosine x. The building extends over a rectangular base 10 meters in wide and along the axis from x equals negative square 4 to x equals square root of 4. So and is 20 meters tall. So the problem is the calculate the volume of the library building considering the complex of shape of the roof. So we so the formulas of volume is area multiplied by height, and area is equals to the multiplied by the weight. We have the weight that is 10 meters and the height is 20 meters. So we know that the length, we have a form an equation for it. So an integral for that. So and that's moving the data of the axis goes here. The x equals square root 4 is goes here, and negative square, because there was the first, this is the last. So b in the formula is ba. So and the other we got the x power to 2, and x squared and minus 2 cosine x. So the x, and now we do the integral here. We separate these two for practicity and for the problem requirements, which is we are going to use different methods to get their integral. So from here, for x2 we are using the most basic one, which is integration by parts, and because it's just x squared, there's not it's an easy one. So we don't have to do much. His derivative is x cubed over 3, and we substitute the values here. We use the formula of the integration by parts, which goes here, square 4 to the cube over 3 minus square 4 to 3 to the cube over 3. We got this, and we got from the result is 16 over 3. And now for the one that is like using using the cosine. We substitute its trigonometric function, which is cosine here. Cosine x d is equal to sine x. So we do here, we proceed to the step 2, which is changing this one for here. It's more like derivative, and then we use the values of the x's, and this is the procedure I got, and this is the result. So Now we got the values of x squared and the values of cosine, I think. So we where is it? Okay, so we subtract the values of x squared and minus 2 cosine. So it's, well, converting the fraction to decimals, it gives 5.33 minus 0.4140 and gives this one, this 5.193. Well, it's more values, but it's like infinite 3, so I leave it like that. So for the area, we multiply in the length, which is this one, multiply with the wide, which is 10. We multiply this by 10, and the results like this. We can leave it here, but because it's the area, but the problem requires to get the volume. But fortunately, we have the height, which is 20 meters. And now the final step is multiplying the area multiplied by 20, and this is the final result. 1038.66666 meters cubic. So that's it. And now we proceed to problem 3.